Thank you, Dr. Wong. Thank you, Joey, for making it easier for me. Of course, you introduced what happens with testing and so on. As we start off, this year at Food Expo, there are 2,000 exhibitors. 2,000. Although, so much variety. So, if you could please help me first and tell me which of these food items excite you? Prepared hot pot coming from mainland China, or packaged food coming from Japan, or fish skin chips coming from Singapore, or white asparagus from Germany. Is any of that exciting to you? If you can show me with your hands. Anything interesting? Or perhaps something else that you have seen at one of the other booths. So, in general, what is clear is we will also need some technical support to have the presentation on slides, Help me out with one final thing. Who of you is interested to try new food? Thank you, Dr. Wong. New food and innovation, That's what Food Expo is about, Food coming from different countries, food that tastes different, where the recipe is different. So food innovation, necessary for development, necessary for people to try out and experience. And at the same time, what we see is if we look back, innovation has always also been there in the manner how food is packaged. So we would have seen, if we look at history and we would hear from our grandparents, it all started off differently. Food was packaged in clay, and then it went on to barrels, and then into metal, and then plastic, and now flexible packaging. At the same time, there has been innovation in terms of packaging, into how food could be put in different forms so that it can be transferred long distance, so that it can be stored for longer safely, and that there's no contamination, it does not harm the food, so that we don't have some of the problems that Joey mentioned before. But while food packaging is very innovative, the basis for that is that it has to support the food. It has to prevent contamination, it has to help increase the shelf life, it has to protect the food from damage so that you can keep it longer and then you can enjoy the main product, the contents of the packaging, the food. So it has many, many advantages, and if you walk around you will see all the innovation with packaging. However, there's something else which is happening with packaging. These are some of the news that made the headlines about contamination in packaging, about mineral oil issues, about harmful chemicals found in packaging, some of the harmful chemicals from the ink getting through the multiple layers and getting to the food. So that's also a problem that has to be looked at from all those new innovative packaging. Additionally, there's another problem that packaging poses, which is for single use. When we get the food, we consume the food, and then the packaging is done. Nothing else to do with it. Unfortunately, a lot of that ends up in landfills, ends up in our oceans, and it has many chemicals to protect the packaging, to protect the food and so on. Many of those chemicals have a link to diseases, to problems, to medical issues, to cancer and so on, which has been proven by international experts. So that's the additional part that people have to look at. So what about innovative, greener packaging, sustainable packaging? When you go for plant-based food, what about it comes with more safer, more sustainable packaging? Well, there's also a problem there. On one hand, the different packaging also poses the kind of energy which goes into the packaging, the kind of carbon footprint that goes into it. That also has to be addressed. Here you see this example which showcases the percentage of carbon footprint due to packaging for many of these large brands, many of whom you would recognize, and we utilize their products on a daily basis. If you look at just Hong Kong, the Hong Kong situation, this research report came out, Eat Without Waste. These are real pictures, these are real numbers. If the current packaging trend goes on, we see the issue with waste. We see the issue with pollution, But at the same time, the takeaway food has gone up, the amount of packaged food has gone up. So that's something that has to be looked at. Going back again, we heard earlier in the presentation about chemical testing, the issue with chemicals, contamination and so on. What is intrinsically linked is safety and sustainability. Both are linked to the chemicals, the issues with chemicals. So what's happening is when you get a chance to go around, you will see not only do you see innovation in food, not only do you see healthier food, greener food, but you would also see more sustainably sourced food. At the same time, you would see these big commitments from all major brands and new startups and SMEs talking about more sustainable packaging, commitments on more recycled materials, commitment of renewable packaging material, commitment about recyclable packaging. Well, at the same time, as it happens in our world, first there is innovation, then there is development, then there are accidents, then there are standards, then there are regulations. That's also what we see all over Europe. Regulations addressing packaging, packaging waste, chemicals in packaging, recyclability of packaging. And not just Europe. You would see the same in China. Over 30 standards are already ready for different kinds of packaging material. Same as in India, my home country. Same as in America. Focus on chemicals, focus on recycled material, focus on safety of recycled material for packaging as well. And then of course, one of the things that comes up in mind is, oh, what about having biodegradable packaging? What if the packaging is coming from bio-based resources? Is it better? Sounds good. Has to be safer. Has to be good for the environment. Well, first of all, bio-based need not always be biodegradable, need not always be compostable. So there are many aspects which have to be looked at. There are certain standards existing in our world today. There's the Bioplastic Association, which has also come up with a set of standards and certification schemes which have to be looked at. Some examples on the right-hand side, both for industrial compostability, home compostability, biodegradability. So when we heard earlier from Dr. Wong about the reliability of those claims based on evaluation by independent technical bodies which have accreditation, well, those are some of the schemes that work on certain standards, which are then, the packaging is evaluated by laboratories and companies which have suitable accreditation, like we heard earlier. So what about the future? What is expected for a circular packaging product? Well, what's expected is it should not have any harmful chemicals, because we don't want to put that back into the circular economy. What's acceptable is it has more recycled materials, so less strain on new resources. What's expected also is that it's recyclable. What's expected is it's easy to understand, easy to use, and still maintains the safety of food. It protects from contamination, it supports with shelf life, it's lighter, its carbon footprint is not so bad. And at the same time, it's not so expensive in terms of money terms. So all of those parts are still expensive. Here is an overview of what's the attributes, the core attributes of circular packaging. Now there's this framework program and which comes up with a scorecard called UP scorecard, or Understanding Packaging, which talks about first the quantitative metrics. When we talk of environmental aspects, we talk of energy, so carbon emissions, we talk of water, so water use, and we talk about what happens end of life. So we talk about pollution aspects, how easy is it to recycle, what about that packaging being edible, so after the food, you'll be able to eat the packaging, for example. But it also has a lot of qualitative metrics about chemicals of concern. We saw earlier from Joey how chemicals are being tested by laboratories, example to look at that. We talk also about sourcing, looking at upstream. We saw from the example from Dr. Wong, the farm to fork approach. So what happens upstream? Where is the packaging material coming from? Has this been sourced and manufactured responsibly? All of that being looked at, yeah? But, as we know, not all packaging is the same. It depends on the type of food, it depends on how far you want to transport it, it depends on how long you want to keep it, it depends on what you want to be the weight of the packaging, how attractive you want it to be, how the consumer should feel about it. Different kind of packaging, which one to use, for what purpose, what are the advantages. Again, it's from a nice report from ADM Capital based here in Hong Kong. It's part about Eat Without Waste report, yeah. So for you, evaluating packaging could be a useful source. So now let's go back. Issue with harmful chemicals, issue with how it's sourced, issue with what happens end of life. So essentially, if we look at the supply chain or the value chain of packaging, starting from raw materials and then it's converted and goes through manufacturing, finally to consumption, and then what happens at the end of consumption? What happens to that packaging after the consumer has consumed the food which was inside? All of that has to be looked at for a safer, sustainable packaging aspect. But hey, we are here talking about food. So yes, the food should not be impacted. Packaging should not contain any of the harmful chemicals. It migrates into the food. How do we check it? We heard earlier about some of the chemical analytical aspects on the product, on the material itself. But what's important is to look at all aspects, the full farm to fork approach. We have to look at the printing ink. Are there any harmful chemicals in the printing ink? You would often see packaging which has multi-layer when it's flexible. What happens inside? When we look for paper cups, which we see are being consumed for beverage and drink, and on one hand we see, paper cup. What's the coating inside? What's the coating inside which is making sure that the water doesn't penetrate? That has to be looked at, yeah? All of those aspects have to be looked at. The ingredients which go into the packaging material have to be looked at. A lot of that is based on technical review by toxicologists, by experts, but also by analytical testing to give assurance to enforcement agencies. That analytical testing, when conducted by a laboratory which has accreditation, like from your organization and structure, adds that additional level of reliability of the data, which all goes into to tell the consumer and your customer or brands that the packaging will not have a harmful impact on the food and hence the consumer. So even when we talk of more sustainable packaging, whether it's recycled material, which is bio-based material, it comes with its own share of contaminants and issues, whether it be pesticide residues, whether it be mineral oil issues and so on. So all of those have to be looked at as we innovate with packaging. We also encounter and discover new issues, new challenges which have to be looked at with scientific methodologies, which is what laboratories or technical laboratories typically work on to evaluate. So this is one example. We heard earlier the word contamination, which are really small. So we would have heard ppm level, parts per million. There's also the ppb level, parts per billion. So how should you look at contamination that comes because of recycled material? How do you look at contamination during the production process? This is what comes through these hidden culprits or NIAS, non-intentionally added substances. These are in parts per billion level. European regulation has a criteria for this. Chinese regulation has a criteria for this. This has to go through specific methods. So if you would have seen the previous presentation of chemical testing, typically in chemical testing, we are testing for a particular heavy metal. We are testing for a particular chemical. But this one is testing for all. So the result of this test is peaks, different peaks, and then based on the richness of the database about what material, what production process can have what contamination, a laboratory is able to say, it could be a particular chemical substance because of that production process. And then a toxicologist would say, well, based on normal consumption by a human being, what is the impact for humans? So that's a new requirement in Europe. It also is already in China. Also called non-intentionally added substances, contamination, breakdown products, and so on. And as you see there, that's a reference for the European regulation. There's also a standard in China and reference to the latest Chinese regulation there. So with that, thank you all for listening, and I hope with the innovative products you are able to identify some of the innovative packages.